Welcome to this tutorial on how to operate your ELM series laser module. To connect your laser module to your PC, you can use a serial to USB converter. Usually, your laser module should already come with a cable tree, including such a converter. On your operating system, you can try finding which serial port it currently occupies. In this case, it is COM4. Inside of the laser controller interface, on the top left, you find the communication settings. First, select the correct COM port, and if your laser is powered, you can now click Connect, and it will start updating the values and show you the interlock state. Currently, the safety interlock is open. I will now close it, so we can start operating the laser. Now that the interlock is closed, we can have a look at the further settings to first operate the laser in the simplest constant current mode. The set current is set inside of this field. We will, for example, set it to 3 amperes. Inside of the thermal management box, you can find the settings for 2 different temperature control loops, for the laser diode and for the second harmonic generator. In this case, we only have a temperature controller for the laser diode, so we only need to set a value here and only enable this temperature controller. The laser is configured so that you have to turn on every applicable temperature controller in order to operate it. So, for example, in this case, I only need to turn on the laser diode controller. You might also want to connect a cooling fan to the auxiliary power supply that is included in our laser. For this, you can use this aux supply button. I have now turned on the cooling fan, and you can see how the heatsink temperature is now slowly climbing down. And you also see the laser diode temperature being stable. We can now turn on the laser. As you can see, the laser diode current and voltage are in their nominal range, and the output frequency of our laser is now stabilizing. If you find any problems with the temperature control loop or with the frequency readout, we provide a settings menu where you can fine-tune the PID control values and the photodiode reference level. This reference level is set as a 12-bit value, and it is relatively sensitive, so you might need to adjust it in steps of 10 until you again get a good frequency readout. You also have a setting for a safety limit that is only applied within this software. You can use it to limit the current to some value, usually up to 7 amperes, because this is the limit of the thermal system. If you are satisfied with your changes to those values, you can use the Save Config to Flash button to permanently save it to the laser's flash, so it is automatically loaded on startup. The flash has limited write cycles, so only save the settings once you are satisfied. You also find a Save button inside of the System panel. It will not only save the PID settings, but also your current presets and the temperature settings and, for example, GPIO and dimming settings. The laser has different dimming control modes. In the simplest mode, off, the laser will just constantly operate at the set current. There are 2 other dimming modes. The first is GPIO. This is used if you want to connect an external trigger onto one of the two GPIO pins to manually turn the laser on and off or to change its operating current. In the basically low dimming mode, the laser will switch to this low current. And in the high mode, it will switch to the nominal set current. If you want to completely turn the laser diode off, you can set the low current to 0. But if you have a microchip laser and you just want to turn off the laser output, but still keep the laser diode with some current so you get faster switching behavior, you can keep it at a ready current below the threshold of the laser crystal. So in this case, this is 2 amperes. For demonstration purposes, I have connected one GPIO to the other GPIO so that I can manually generate a signal on the GPIO input. In order to use the input as the dimming input, I can select the function LD dim, click apply, and I have now changed the function to the dimming input. The output function is now only connected to this button, but if you're controlling the laser via the serial interface using your own microcontroller or other control application, you can use that to set this output pin to control other instruments or as a synchronization output. To actually use the dimming, I still need to turn the laser on. And as you can see, it is now turning to 2 amperes, not 3 as set here. And if I now turn the output high, you can see how the laser is now switching to the high value. If I turn it off again, it is switching back down to the low value. The third dimming mode is pulse. Inside pulse mode, you find this pulse generator box. The count is the number of pulses the generator outputs after it is triggered. If you set it to 0, it will continuously output pulses. If you set it to a number, it will output this number of pulses and then switch off until you trigger it again. The width and period are set in milliseconds. In this case, I set a pulse width of 200 milliseconds and we set it here down to 2000 milliseconds. I can apply the setting and now I can turn the laser back on. And you can see the pulse generator starts somewhere within its cycle. You might find that invalid values within any field might cause the value to not be correctly applied. So, as you saw previously, you might need to correct the value again so it gets applied correctly. Now you see how there are 200 millisecond pulses within a 2-second period generated, and you see the frequency, it is generated correctly. Now we can use that to, for example, generate high frequency bursts without the adequate cooling capacity. So for example, if I increase my period back again to 10 seconds and increase the current to 7 ampere, You can see how we now get nice high frequency bursts and leave enough time for the heatsink to cool back down again. And we might also be able to decrease the period a bit. I will now also demonstrate how to use a finite count. So for example, if I now use a period of 1 second and maybe let's generate only 3 pulses. And you see here, we have 3 generated pulses and now it has stopped until I click on it again. And of course, if you want to automate the laser, you can just send the serial command and it will also re-trigger on that. Now we can turn the laser back off. And this was the demonstration on how to operate the ELM series laser module. In case you have any questions, you can always write us at info@laphtec.com.